Okay, hello everyone, and welcome to a special edition of Handmade Hero. Today, my very special guest is Shawn McGrath, who many of you already know because he does programming streams as well that you've probably watched. Essentially, what we're doing today is a while back on Handmade Hero, and I, to be honest, have completely forgotten the reason it initially came up, because I think it came up even before potentially we did the career stories stream. So my temptation is to say it was part of the career stories stream, but in reality, I think it came up before that. I was talking about how the interview process at tech companies is not something that I particularly agree with personally, and I was trying to explain how a fellow named Chris Hecker, who is actually the primary developer on a game called Spy Party, which you may have heard of, but he's been in the industry a long time. He worked at Microsoft, did WinG back in the day, and he did the animation system and the creature morphology system for Spore, which is pretty awesome tech if you've never seen it. So he actually has an interview process that he taught me, and that I think is really, really good. I can't say one way or another what the perfect interview process is, but it certainly struck me as an interview process that is dramatically better than what people tend to use today when you see how tech interviews are conducted, and how sort of like companies like Google or Facebook or this Microsoft conduct their interviews. And so what I wanted to sort of get across was how that interview process worked. And on the stream, Shawn actually said, hey, if you want to do it, I'll just pretend to be an interviewee and you can pretend to be the interviewer and you can do the interview, and so people can see how it's done. And I was like, that sounds awesome. Now, unfortunately, I'm not Chris, so I'm probably not as good at it as patient zero, but I probably good enough at it that you should be able to see how it goes and kind of see, oh, okay, I get it, I get how to do this. And it does require a little bit of practice on the part of the interviewer, but that's how it goes. So, first of all, Shawn, thanks so much for being with us.
Oh, no problem.
You have said you've got a sore throat today, so I apologize for that we're putting extra strain on your voice. But
this has been a month-long struggle, so it's okay.
It's the winter time, right? That's how that is.
In Canada.
In Canada.
Yeah.
How deep into Canada are you, Shawn? I don't know.
I'm just in Toronto. It's not that
Okay,
bad.
so you're not that deep. I remember.
I'm further south than you are, but it's way colder.
Okay, yeah, because we've got the weird temperature inversion here or whatever nonsense.
Yeah, you've got the Pacific Ocean.
Okay. Well, so let me just say a quick thing about the interview, and then we'll sort of pretend to get started. I'm going to try and start at about 11:30. So the idea behind this interview is sort of to correct some of the problems with the standard interview process that you see in tech. And one of the things that you typically see in tech interviews is programmers are given like a programming problem of some kind, or a tech problem of some kind, or a brain teaser of some kind. And you've probably seen this sort of thing mentioned a lot, discussed a lot online. There are books now that purport to train you or show you the kinds of programming puzzles that you might face if you are going to try to get a programming job. And that's very endemic to how the programming industry at large kind of does these sorts of interviews. And just personally, and also I think other people probably can attest who've gone through these interview processes, a really big problem with this is that it has nothing to do with the act of programming. And you may say, well, it's a programming problem, surely it has something to do with the act of programming. But what I mean to say is the fundamental construct of coming into someone's office that you've never met before, being presented a relatively, potentially, depending on the circumstance, a potentially tricky programming puzzle, and being asked to solve it on the spot is nobody's job in tech, right? That is not something that you ever do day to day. A programmer's job is a marathon, not a sprint. You spend many hours programming. Most problems of any non-trivial nature, you will spend many hours acquainting yourself with first, becoming comfortable with the concepts, reading about what other people have done in that area, forming opinions about what might be the right ways to approach it, experimenting with the code. And whether or not a particular programmer can solve a puzzle in 30 minutes is kind of irrelevant to whether they'll do a good job on a programming problem given a week or two, which is what you actually care about in the job. And so the big problem with the way that programming interviews are conducted is they focus very much on this, and it's inherently kind of an adversarial process. You're giving someone a puzzle, you know the answer, they don't. You are forcing them in an already pressure situation to perform under pressure, pressure that will not be there in their actual job. They will not have you hovering over them when they're attempting to solve a programming problem. They may be someone who's very nervous by nature, and this may make it very difficult for them to concentrate. They may be self-conscious about their own programming ability, even though they may be very good. They may still be self-conscious, and this will affect their ability to solve the problem in a situation where they feel like they're being tested. So there's all of these things that kind of conspire to really, I think, produce unfair results in the process. And that's not just a problem for the person interviewing, who will get unfairly potentially rejected from a job, even though they might have been the best person for that job. But it also hurts the hiring side, because you may be turning away lots of people who would have been great at your company and very good at what you needed them to do, simply because their personality or their mental state at the time is not up to the task of solving these pinpoint pressure kind of problems. And so what this interview is designed to do is to sort of get past that as the central the central turning point of a job interview, and try to turn it into something more friendly and comfortable, so that the programmer isn't constantly aware of this pressure, and to maybe get them out of that headspace so that they can behave more like they would in the real work environment, which is, I think, a fairer test of their ability. So that's all I wanted to say as the preamble. And I also, again, apologize if I don't do the best job on this. Maybe someday Chris Hecker will demonstrate it on his stream. He streams occasionally. Maybe he would stream one where he would interview somebody and he can correct any mistakes that I make here. But there we go. So without further ado, we're going to pretend that Shawn and I don't know each other, even though we do. And we're also going to pretend that I haven't ever seen him stream code. So I'm going to pretend I don't have any knowledge of anything that he's done. And I'm going to have to get all of that information out of the interview myself. All right, Shawn, you ready?
Let's do it.
OK. So hey, Shawn, thanks for coming in today. How you been? How's it going?
I have been great, other than my sore throat.
Yeah.
How are you?
I'm pretty good. I feel like for whatever reason, Saturdays I sometimes have trouble getting up in the morning at the time that I should. So I've got some coffee here. I hope it's going to kick in. If I seem a little bit dopey, that's not representative of our company. That's representative of the earliness. So I apologize up front for that.
Same, because I stayed up until 6 in the morning playing Dota. So.
Oh, awesome. Do you like Dota?
Oh yeah.
I mean, I assume if you stayed up till 6 playing it.
Oh yeah. Well, 6 in the morning my time. That's only like 3 your time.
So do you are you like a fan of online games in general, or MOBAs in general, or do you like is that like an anomaly? Because sometimes Dota or League of Legends is like an outlier for people.
Yeah, no, I'm a big fan of esports. I followed the Korean esports scene since like the late 90s.
Oh wow.
And I've just sort of been enthralled by that. But by the idea of these sort of, they're not really games at that level. Like they're no longer, they break down the video game part of it and become like this almost like mental chess with crazy reflex sort of like one-on-one experience that I really enjoy watching. So I've been a fan of that, and I think Dota is currently, although StarCraft Broodwork has come back thankfully in Korea, but I think Dota is sort of the pinnacle of that at the moment.
What got you into Korean esports that early? Because I feel like, a lot of people probably were, well, in the late 90s, I think a lot of people probably weren't aware of that scene at all, or, kind of what even the gaming scene was like in Korea if they weren't from, that country or thereabouts.
Yeah, I don't know. I've always been a competitive person. So I played lots of sports when I was a kid. And then when I was 12 or 13, I got into programming, and I started making video games, and that's what sort of got me into video games. And I didn't have time for sports anymore because all I was doing was programming. so I had to get like something, or playing games and programming. So I had to get like some sort of competitiveness out. So I started playing video games competitively, and at the time, Warcraft 2 was sort of the
Oh wow.
most viably competitive game, and then StarCraft came out, so I was playing that, and then I found out that some shoe company was making StarCraft shoes in Korea
No way.
in like 1998 or 1999, and like now that doesn't seem like a big deal, but like 20 years ago,
Yeah.
like video game branded shoes, that's crazy. That would never happen here. So I was
Right.
like, in Korea, they go crazy for this. This is interesting, right? So I started doing a little bit of research on Korea and esports, and that was when a French Canadian player named XDS Grrr moved from Quebec to Korea to compete. And I
Oh
was
wow.
like, oh my god, this is crazy. So I was like, this is what I want to do. So then when Warcraft 3 came out, I played it so much that I was top 100 in on US East,
Are you
which is
serious?
like, yeah, I was
I
like,
oh
really good
wow.
at the game. Yeah, so I don't know. I've just always found I'm really competitive, and I don't really like video games anymore, but I used to really like video games, and I like programming. So it's sort of, it's a natural sort of thing.
So tell me a little bit about that, because like this is something that I've never, for whatever reason, like competitive gaming, I've almost never gotten into. I don't know if that's just because I'm just bad at it, so I don't like I'm not as interested in doing it because I don't think I'll be good. I'm not sure though. I've never quite done it. So like, do you generally like is it? I feel like looking at your resume here, like it doesn't look like you've ever really worked on esports kind of titles. Is that because you like to keep that separate? Like you like to kind of have esports as your recreational activity, and you'd rather work on like single player games or stuff like that as the job? Or is that just circumstantial? Like it's like, hey, I never really had the opportunity to go work on a esports title I was crazy about, so I didn't, and someday I'd really like to, or like, you know what I mean? Like, how does that fit in for you?
Yeah, I've sort of like all the joy of video games, like playing video games, is basically gone for me.
Oh,
I don't
me too,
enjoy
to a
playing.
certain to more than I'd like to admit, I suppose.
Well, it's just like when you make them for so long, right? You see how the sausage is made, and
Yeah.
whenever I play a game, all I just see is like 100 suffering people, right? So it's kind of like I kind of don't get joy in playing video games anymore. But I find that the technology and the technology requirements and the sort of programming ethos that exists in video games is the only one that I'm interested in anymore. And I still find really interesting problems that are more or less only available in video games. And like the programming style that I like is
Ah,
more or less only appropriate to video games. So I still really enjoy the technical problems of video games and solving those problems. But actually
gotcha.
playing them,
Less.
that's long gone.
So what kind of technical problems are we talking about here when you say like the ones in video games versus, some other kind of thing, right? Like what's an example? Just so I just to frame, I mean, I think I can guess, but I don't want to put words in your mouth, right? Like I mean, you probably have a very more specific idea of what you consider an interesting technical problem.
Yeah, I don't know. It's just like anything that's like where we actually care about the resources of a system and we want to do take maximal advantage of them to a point, right? Like
Right.
there's crazy optimization stuff that I find interesting, but it's not like practical to do that on a wide scale basis. But like just generally, like, okay, this is what our hardware is. How many triangles can we get on the screen? How many times can we overdraw pixels on the screen? How much transparency can we have? What sort of things can we do in this space? Like, how should we partition our geometry? How should we tessellate things? All of these things. All of these questions are how to maximize what result we have, whatever we want that result to be. And it's not like, I know like Facebook or whatever, they're going to be like, well, we can get 1% more out of hip hop VM or whatever, right?
Yeah.
And it's like, that's just not as interesting of a problem when the solution can be just go build a data center and heat the planet up another degree. Where in where in games it's like, no, you have this one x64 thing, make a photorealistic screen happen, or make a photorealistic image happen on the screen 90 times a second, right? Like, how do you do that, right? And in that there are tons of little interesting little technical problems that I enjoy solving.
So, which it looks like you did two major games here, Dyad and N++.
Yeah.
Were there others that you enjoyed doing, or those were? I mean, did you like those projects? I guess I should say. Like, how did you feel about them,
Yeah,
respectively? Or are there other projects that you preferred to those that maybe I'm not aware of?
Yeah, so I've done I did the sound effect system for sound shapes as well for the Vita and the
Oh,
PS3. I did the back end and part of a scripting language implementation and rendering implementation in Flash for an MMO back in
wow.
2005 or 2006. So I did the entire back end for that, some of the renderer, a scripting language thing. So I've done that. I've done contract on small contract work,
Yeah,
like, hey, we need to make this load in less than 4 hours, right? Stuff like that,
yeah.
or how do we split this geometry up so that it's faster? I've had little contract jobs like that on various projects, but yeah, the biggest ones are Dyad. I did everything myself except the music, which is a lot of work. Like all the
Yeah.
design, all the art,
Oh
all
wow.
the
Okay.
publishing stuff, like everything. And then M++ I just did the programming,
So,
but only on the PS4 version, not the PC version.
which of those projects was your favorite, or I mean,
Dyad.
did you have a clear favorite, or did you just kind of like? I mean, give
No,
me some
Dyad.
perspective on them. Dyad.
I was so burnt out after finishing Dyad that I didn't play it for 3 years, and then when I did play it, I had like tears
Oh wow.
about how much I loved the game. It's like my favorite game.
So,
So like
so
I loved everything about it, and I assumed that I was going to hate it at the end of it because it was such a traumatic
yeah.
experience, right? And then, but when I played it 3 years later, I was like, "This is the best game I've ever played in my life." So I
Well,
felt really good about that.
so did you feel like that project is your favorite from a game playing standpoint and also a technical standpoint, or did you feel like technically other projects were more interesting and Dyad was more just the end product was your favorite? Like, which was your favorite to have done the work for versus to play? I guess does that make sense as a question?
Yeah, I think one of the so there's a couple of interesting things that I did in both of those two games. We'll talk about the two games because those are the ones that I was primarily I
Sure.
did all the programming for both of them.
Yeah.
So in Dyad, it loads about 100 megabytes of textures and about I can't remember 130 megabytes of sound on the PS3 with no load times.
Ah.
So there was a lot of asset pre-processing and just mapping everything out into chunks that you just mem copy basically, and then just set the pointers up.
And what's the
Some of
PS3?
it,
Refresh my memory, because well, and actually, I shouldn't say refresh my memory. I never actually shipped something for the PS3. So, what? I don't actually know the PS3. What kind of constraints were on the load times there? I mean, was this loading from a disk or downloadable?
it was downloadable, but like it's the hard drive is super slow,
Okay.
and it was segmented memory, or well, not segmented like the old ways, but it wasn't unified memory where the GPU could access CPU memory. So there were two separate things. But I ran over the budget on the CPU side of things, so I had to chunk some of the sound onto the GPU memory, and then the SPUs can read to both. So there was a lot of, but you're talking like 8 years ago at this point, right? So, but yeah, so there was a lot of that. That was interesting, kind of like, it's kind of dumb work. Like, it's like, oh my God, this is such a stupid constraint. How do we solve this thing? But at the same time, it's also like, this is kind of an interesting solution, right? Like, it's kind of an interesting problem of like, how do we get this thing to not have to load? Okay, so it's a big endian machine, so you got to put everything, you got to do an asset pre-process on everything to put it all into big endian. What if we, try different texture compression things? It's like, well, what if instead of texture compressing, we just used 4 channels of uncompressed texture and then applied a color to each channel? So essentially each channel was used as an alpha mask. So that was the way I did texture compression, so that there was no artifacts around anything.
So
So
hold on a second, because there's a bunch of stuff in there. I just try to make sure I understand. So let's starting with the loading stuff. So basically, like you have to. It sounded like you had maybe around 250 megabytes of asset footprint. It sounded like.
it was a little bit more,
Something like
more
that?
like 300. Yeah,
More
something
like
like
300.
that.
And that
I
is
think
that
there's 512 megs on the machine. So yeah.
is that like the uncompressed footprint, or is that the compressed footprint?
There was no compression.
Okay. So the uncompressed footprint is 300 megabytes. So once the 300 megabytes is in there, we're good. But again, we've got to get it off the hard drive, which is going to take probably at least 20, 30 seconds, probably. I don't remember what the speed of that hard drive was, but
It wasn't that long, but it was over 10 seconds.
Over 10 seconds. So, so what was your approach to that? Tell me, like, did you just try to load everything? Like, was it background streaming? Like, give me some idea of what the approach was. I mean, so I know it's probably hard to remember, but just so I have.
Yeah, but basically it was like because the levels were fairly linear.
Yeah.
There was a lot of assets. This was all done manually. There was a lot of assets that were duplicated across multiple levels, so they just always stayed loaded.
Okay.
Right. So, but that was like 100 and something megabytes.
Okay.
And then there was another 100 or another 300 on top of that.
Okay.
So those 300, because they were linear at the start of the level, or sorry, the levels were linear. At the start of the levels, you would need, we could figure out what assets you needed right at the start, and we stuck everything was, there were two files. There was the GPU file to go into the GPU memory, and the CPU file to go in the CPU memory, and they were just ordered. Like the things that you needed at the start were used at the start, and then there was a thread that was just mem copying everything, and hopefully by the time a pointer needed to be there, the memory was there.
Oh, okay. So tell me a little bit more about this then. All right. So I'm going into, well, let's say the startup of the game needs, I guess it sounds like 100 megabytes or something or 150 megabytes of startup data. It sounds like you were sort of saying. How does that get in there, or is that just?
That happens during the save game because on consoles, the save game API. I read this article about ETW being the worst API ever made, and I don't necessarily.
But it's not. Is that what you're saying?
It's not. It's console save game APIs are the worst APIs ever made.
Okay, tell me why.
I can't just like. The number of asynchronous things you have to keep track of, and like the number of states that can just suddenly change, and the number of TRCs that are related to save games is just absolutely ridiculous.
Got it.
And you have to mount and unmount things, and there's no like file replace where it automatically makes a backup copy, so you have to do that manually.
Okay.
And then it's an absolute nightmare, right? Okay. And just mounting a save game, like mount point, because I guess they're CH rooted or something. I don't know how it works internally, but like mounting a save game mount point is like a 3-second API call, and then unmounting it.
So you have to overlap it because
you
can't just sit there for 3 seconds going like, hey.
No, you fail TRCs immediately, right? Because I think you can have like half a second or something where your screen doesn't refresh.
Okay.
So it's just awful, right? And there's no good, like the asynchronous APIs, at least on the PS3, weren't good. If I remember, like the file IO APIs.
Okay.
There were, yeah, but I never used them. I just made a thread and did everything manually in a separate thread, right? So it wasn't like file read in Windows where you pass it the overlap thing and then just let the OS take care of it. You manually did the threading. So it was just like a bunch of dumb stuff, and you always do that at the very end, which makes things extra frustrating.
Right.
So while that was happening, the save game stuff was happening, we were able to easily load the 100 megs that you would need for the whole game.
So basically, you could issue an IO, like you could issue IO for the data that you needed, and it would be able to complete in the time it took to wait for the save game to mount.
Yeah.
Wow.
Yeah.
Okay.
Yeah, because the save game is like 12 bytes or something like that, and it still took longer to load those 12 bytes than it did to load 100, whatever it was, 96 or 100 megs or something like that.
Okay, so that comes into memory, and you've just got it, is what you're saying. And I guess, is that partitioned as well? You kind of were talking about it being partitioned between CPU and GPU, or how does that work?
No, that's all CPU memory.
Okay, so it brings that in.
Except for some textures, but it was small.
So then, now, I go to start playing a level, and I'm sort of going through this level, and you said you've got a background thread going, and you said something about hopefully the pointer's there. So tell me a little bit, what does this thread do? Like, give me the walkthrough.
Okay, so if I remember correctly, most of the data was sound, and if you're into jokes, because you seem to be having a good time,
all right.
One of the marketing things that we did for Dyad was uncompressed audio, right? And because audiophiles think they hear things that they can't. So, all
right. So this is like you were like, "Hey, look, guys.
Hey, look,
no
we have
compression.
Audio. No audio compression.
No crispy digital artifacts here."
Well, I'll get to that.
All right. Hit me.
We didn't have audio compression only because it loaded faster, right? And because all of our sounds, there was no music in Dyad. everything was the stem of all the songs. And then I wrote a dynamic mixer, right? So it'd be playing like 30 or 40 loops at a time, and like any event that you do in the game would dynamically change everything, right?
Okay.
And so chord changes and stuff like that were all manual, like we would just swap what sounds were playing, right?
Okay.
So it was complicated as hell. But in order to do that, in order to get the decompression, because there's an overhead of decompression with OGG files when you first started up, if I remember correctly, and then we couldn't use MP3 because there was a royalty thing at the time. Anyway,
yeah, so it was still patented up until like last year, I think.
Yeah, it was still patented, so that was a nightmare. So we were just like, screw it, we can just do it all with just raw PCM data. So when we were marketing the game, we were like, hey, raw PCM data, but the original samples that we used were like 32K MP3s, like they were just terrible, right? But like we uncompressed them for speed purposes and just told everybody it was uncompressed audio, which was totally true. So we did that.
Oh man, okay.
And people like on forums were like, man, the audio is uncompressed, this is so good. And we're just like laughing because it's like, yeah, it's uncompressed from compressed.
Oh man.
So anyway, so what we would do is at the start of each level, there would be like a list of, 60 or 70 WAV files that we would use, and the memory offset to where they were. And we would line them all up so that the first chunk of the memory was music that you needed at the very start of the game, like the first, because like I said, like there were all the chord, like we'd have like 7 sounds in a song, and there'd be like 5 chords for them, right? So that's 35 sounds, but we know that we're starting on C major. So we put C major first, and then we put all the sound effects that are for C major, and then we, maybe it goes down a fifth or something like that, and we'd put that as the next chord, right?
Okay.
So that's just how it all worked.
Okay.
So we'd put the first chord that you needed first, and the second chord that you needed first because the levels were linear.
Yeah.
And then the header of the file was the byte offsets to all of the sounds that we needed.
Okay.
And we would just hope that by the time you got to that part of the song, that part of the level, that loaded. Otherwise you'd hear noise, and it never happened. So we knew it was fast enough.
So basically you have this table that says here are the byte offsets, and we're going to jump to wherever that's supposed to be, and we're going to start playing that WAV file, whatever it is. Now, hopefully the background thread has loaded that in by now, but maybe it hasn't. So does the background thread loading in chunks, or how is that working?
It was just a mem copy, or it was like a loop of mem copies over, I don't remember, a megabyte, like, was it 96? I don't remember exactly how it worked, but it was like a loop of mem copies. It would just keep doing it. That way it would update a progress indicator of when something was done, so we would know if we ever missed.
What do you mean by mem copy? Because it's coming from a hard drive, isn't it?
Yeah, you just map the file in mem copy.
Oh, okay. So it's using a memory mapped I/O, not like an fread sort of style, or
right.
Sort of. Okay.
And it would do a megabyte at a time, because I found that to be faster just experimentally. Like I do do we map 4 megabytes? Do we map the whole file? Like how do we do it? And then what ended up being fastest, if I remember correctly, was 1 megabyte, but now I'm thinking it might have been 2 megabytes. Whatever it was, I did a bunch of tests about how much we want to map. What if we just map the whole file and then just do offsets? But that didn't work because the OS scheduler couldn't predict what it needed in memory correctly if we were jumping around a lot. So
I see.
I mapped what I needed. I mapped a small chunk of what I needed, and then would just continuously map different parts of the file and then mem copy it into a fixed chunk of memory.
I see. So basically, your original approach was just to memory map the file and say, hey, we can just play right out of that. But it was too much just in time, like you'd hit it and need it, and the OS wouldn't have had time to go get it.
Right, basically. And like the OS, it doesn't solve all your problems, right? So it doesn't know. It didn't know what we would need, but we would know what we would need, so we would be able to figure it out.
Got it. Okay, that makes sense.
Like if I could have just memory mapped the file, that would have been amazing. It would have been less work.
So, all right. So, I guess going back to the original question there. So, technically speaking, which of the projects did you think was the most fun? Right? Was it Dyad or was it N++? You haven't mentioned anything from N++.
N++ had a lot of unfun things about it regarding the tech that I don't really want to get into.
Oh, okay.
Especially on stream.
Okay.
But there was one interesting thing about the N++ tech, which is how the anti-aliaser worked.
Oh, okay.
Because
how does the anti-aliaser work?
It's a line art game. Okay. So because it's a line art game, we're like, wow, there's a lot of pixels on a screen. Let's make them as pretty as possible, right? Because it's just line art.
Okay.
But how the anti-aliaser works is a little bit of a, it's a little bit insane.
Okay.
It's every pixel that every line that's drawn is drawn as either it's a signed distance field of either a circle arc or a straight line, right? Everything is a circle arc or a straight line. So
Okay.
we would draw, I'm going to do a little Milton business here.
Yeah. Could you? That'd be great.
All right. So what do we got? Screen 2. Let's see. Okay. So basically, what I'd write a shader and what you would pass to the shader is, P0 and P1. And there was a CPU side. I tried a geometry shader. Don't use geometry shaders. So I did this on the CPU side, where basically I'd say I want to draw a line between here and here.
Okay.
And it would generate a triangle strip, with points like this or whatever, right? So it would generate, your 6 points. I tried vertex indices too, but it was faster to just draw 6 points. So there was a function that was like draw a line between here and here, right?
Mhm.
So it would figure out what these 6 points are and draw it, right? And it would figure these out by 2 parameters, thickness of the line, right? So that your thickness of your line is this, maybe, right? So you want to draw a line that's maybe this thick, and everything's a capsule, not a line technically, right? Because it's a signed distance field. So
what do you mean by that? Explain what you mean by signed distance field.
So a signed distance field, well, a distance field is basically a field, like a 2D plane or a 2D, I guess it could be 3D, a surface where every point on the surface is a function that is a distance to something. So if you
I'm not sure I understand. Can you? I mean, yeah.
Yeah,
Could
I'm going to draw it out here.
Okay.
So let's say we have this square, right?
Mhm.
This is our field. We'll call this our field.
Okay.
Let's say you have a circle in the middle, right?
Okay.
Each point on this, rather than it being whatever you envision a point to be, it is a function that is it's a function that you can evaluate each point at to be how far am I from this circle, right? So you could say from this point, the value of this point here, the value of this field is the distance from here to the point of the, it wouldn't be a circle technically, it would just be a point, right? So you have a point at the center. So this value here is whatever this distance here is, right?
Okay, so this is like a mathematical function.
Yeah, it's a function.
What does the function for that look like that you draw on there, if you can?
The
function
for this?
Yeah, like what's the actual function that we're talking about here, just so I understand before we go further.
So we'll call each of these points Q, and we'll call the center point P.
Okay.
It would be P minus Q, and then the length of that, which is like P dot X minus Q dot X squared, or the Pythagorean theorem. You know what that is.
Okay.
You don't want. Yeah. So basically, it's yeah. It's just that's not what it is at all, but you know what it is.
Well, no, I'm not, I just want to make sure I get it. Like so okay. Yeah, can you just write out the function so I can see it, and that way, when you're talking about the capsule one, I can look back at it, if that makes sense, and know.
We'll make V is equal to P minus Q, which is the vector of that.
Okay.
And then so V dot V, and then the square root of V dot V is going to give you, well, you don't actually need the square root. So V dot V is going to give you the squared distance from here to here, which is the value of the function, right? So
why don't you need the square root?
It's just an extra square root that you don't have to calculate. Like, why evaluate the square root if you don't necessarily need it, right?
Oh, right. Oh, I just meant like, so if I've got this V dot V, and I'm
that just gives you the square. So that gives you the squared distance, right? So it gives you a squared fall off, right? So instead of having a linear, like if you were to look at the distance fall off from the farthest point to the nearest point, right? If you don't take the square, if you take the square root, you get a linear function. But if you let's try it this way. If you don't take the square root, you get like a function that looks like this. Okay. So you technically do need to take the square root.
Okay.
Because you want to get a linear fall off, right? If you're doing, I'm going to explain why. Hold on, let me see if I can explain why. So the reason why you do this, so if you were to take this and just look at the function, right? I'm going to open Photoshop here. So in Photoshop, if you were to take, come on, Phil. Photoshop crashed. Okay.
That's
All
awesome.
right. So if you were to take a look at just what the function looked like,
Yeah.
you'd get something like that. So that's going to be what your distance field looks like. Actually, I guess it would be inverted. So that's going to be what your distance field looks like, right? So out here in like, let me see if I can go red here. So like out here, you have a distance of say 1 because you're going to normalize it over the area of the thing. And here you're going to have a distance of 0, right? So using this,
sorry, normalize it over the area.
or normalize it over the half width of the square, right? So if you have a square here and this is 512 pixels,
Okay.
so you know that, well, this is going to be square root of 512 plus 512 squared. So whatever this distance, well, we'll just use 512 for example, right? Because we're going to treat this as a circle, right? So if we do that, Photoshop is not cooperating. So let's just say, for example, we'll pretend that I drew this centered, and let's see, edit stroke 2. It's in black, and I wanted it in red. So we'll do this.
How about cornflower blue?
You want cornflower blue? Let me see what I can do for you here. Some blue here. Is that cornflower enough for you?
Yeah, it's got to be corporate.
Okay. Well, whatever that is, that's what it is, right? So we're drawing a circle. We're gonna say that, for sake of argument, that this is 512. This is 512 pixels. Jesus. This is 500. Can I get the proper button? All right. So we're going to say this is 512 pixels, right?
Okay.
So you would draw a square that's exactly 512 pixels. And then at each point on the square, you compute the distance to, say, the center point, right?
Okay.
So right here, and then you divide it by 512 so that you have a normalized value between 0 and 1, right? So at this point here, the farthest point on the circle is going to be distance of 1, and your closest point is going to be a distance of 0, right? Does that make sense?
Okay. Yeah. Could you do that on the equation you had back on the other page there, just so I make sure we got it?
How do I operate this program?
That's a very good question.
Okay. So what are we drawing? What do you want to know?
I just wanted to see. So you said like normalize it to the thing, but I wasn't sure. I just wanted to know like what exactly is going on math-wise here, so I could have an understanding of that.
So we draw our square here, right?
Yeah.
And then we're gonna use in the pixel shader. We're gonna evaluate the distance from wherever point we are, right?
Uh-huh.
So into the pixel shader, we pass our PC, which is going to be this point here, which is our position center.
Okay.
And then we are going to know our pixel position at each of these, right? Because this is just going to be our transformed position out of the vertex shader. And then so we'll say that for sake of argument that this is 10, 10.
Okay.
And we're going to say the first pixel here, we know that that's going to be, let's just say, let's switch this to 100, 100. So we're going to say that this is going to be 50 on X, and we'll say 150 on Y. This is going to be 150. Jesus, this is not 150, 150. This is going to be 150, 50. And this is going to be 50, 50. Did I do that right? So at each one of these pixels, right? So we know that this is 100 across, 100 across, right? Mm-hmm. So we take any point at every single pixel in the pixel shader that we draw. We can take, say, this point here of 150, 150. We subtract it from the center point, which we pass as like a uniform or something. Yeah, it wouldn't be per vertex data. It would be it would be per vertex data because we would batch our draw calls. But so we have in the vertex shader, we have the center point. So we take 50, 50 minus 100, 100, and we get a vector that's 50, 50.
Okay, so which are those 2 points there? You've got 150, 50.
This is PC, and this is P, just P. PC being the center point, and P being P. Okay. And then, so you subtract these 2 points, and you get 50, 50.
Okay.
And then the length of that is just Pythagorean theorem, right? So 50 squared plus 50 squared, square root, right?
Okay.
Which is 2,500, 25,000, square root of 5,000, some big number.
Okay, so why did you
76.
subtract P from PC instead of the other way around?
Doesn't matter.
Okay,
Because
why doesn't it matter?
because once you square it, the negatives go away anyways, and because it's just a distance, it's just an absolute value, right? So if you were to take this point and this point, you're going to get the exact same distance regardless, right? Signs don't matter
Okay.
at that point because the square removes the sign.
Got it. Okay. So now you were saying before the sort of started on this, you were saying that you didn't need to do the square root. So
Well,
you've got the square root
you
here.
do.
So okay. Oh, tell me that part. You do need the
need
square
to
root?
do the square root.
Okay.
Yeah, because so the reason is um so how the anti-aliasing works. It's important for how the anti-aliasing
Okay.
works,
So
right?
sorry, I interrupted you before. Yeah.
Sometimes-
Tell me that part then.
Yeah, so sometimes you need the square root, sometimes you don't. It depends on how much you're anti-aliasing
Okay.
and how wide across you're anti-aliasing.
Okay.
So what we do normally is, by the way, this isn't the equations that we used, and I'm not going to remember what the equations that we used are because I didn't derive them.
Okay.
Christer Erickson did. They're all in real-time collision detection, right?
Okay.
Just very simple, primitive distance to circle arc or distance to triangle.
Okay.
I could do it, but I'll be here for hours.
Okay. Yeah. I understand. I just want to get a cursory understanding.
Right. So this is the to a point, right? But you're actually doing 2 points, and the closest to 2 points or closest to a circle arc, which are much more complicated.
Okay.
By much more, I mean they're like 8 lines of code, but like I can't remember them exactly.
Okay.
So basically, so what you would do is a very simple thing would be like if this point, if this here, right? So that we're going to call this, we're going to try to draw it. We're going to call this D, right? So you compute D, which is distance, right? And you do that at every point in the pixel shader, and you say if D is greater than the radius, then this pixel's alpha value is 0. If D is less than the radius, then this pixel alpha value is 1, right?
Okay.
That's you don't actually do the if, you do step, which is an OpenGL function that just steps between a range, and if it's higher than this, it gives you a number. If it's lower than this, it gives you a number, right?
Okay. So it's like a thresholding operator.
Yes, it's exactly what it is. And that will give you no anti-aliasing and a very hard edge, right? And if you do that, you can just square the distance that you want to be and then save yourself the square root.
Now, why is that the case?
Algebra? What do you mean? Why is it?
Well, because I've got this value, and if I square root it, I'm going to have one thing, and if I don't square root it, I'm going to have another thing. So why can I feed this? Do you know what I'm saying?
So let's say you want your evaluated radius to be 10. Okay, so you do your square root here, and you get the square root of this is square root of 5,000, right? So that's going to be 77 or something. So you take you can take the square root of 5,000 and then check it versus 10, or you can take 5,000 and check it versus 10 squared, right? It's just algebra, like r less than or equal to the square root of, we'll call it t minus v. There. Proper math, p minus v, right? So you can do that.
Okay.
Or you could do this, and this implies that there's a square root in here, right? Because that's this formula here. So because this implies a square root, you can skip the square root, and you can get px minus py, or px minus pcx squared plus py minus pcy squared, and then you'd normally have a square root.
Right.
But you can take the square root off of here and then just square the other side of the equation.
I see.
And then you get, it saves the square root, which
Okay.
used to really matter, but now it still matters, but it's not like the end of the world. But anyway, so you could save the square root if you don't need a linear gradient in the vector field.
Got it. But now you're saying, okay, so for the anti-aliasing part, which you're about to explain, you're saying maybe you do still need the square root.
It depends on how much you're anti-aliasing by, right? Because like I said originally, when you generate the triangle strip around the line that you want to draw, you're either using, you're passing 2 extra parameters, the thickness of the line and some sort of a fall off, which is how blurry the line gets, right? And that's what your anti-aliasing is, right?
Okay.
So if you pass 1 pixel as how thick you want the line, probably can't tell. Okay. But if you want the line to be, if you're on a 4K display, where your anti-aliasing is really, really tight, you're going to want 2 pixels of anti-aliasing because it looks a little bit better. Especially, so our test for this was we took a black background We took a white 1 pixel line and spun it very, very, very slowly. And look at that, and we're like, okay, where's the highest amount of artifact? And then tweaked our threshold value for how much we wanted to blur it out based on the worst case scenario in that situation. And that's how we got the anti-aliasing.
Now, can you give me a little bit of an understanding here, because I'm not sure I totally understand. When you say how much anti-aliasing you want, what do you really mean? Like, can you draw that? Maybe. Yeah. Go back to that.
I'm trying to get to that.
Okay, sorry. So hit me.
No, it's okay. So if you look at I'm going to delete all this. You don't need this anymore.
Nope, I've got it. That made perfect sense. Thank you.
Okay. So when you draw a straight line, I'm going to do this in Photoshop because I'm more familiar with that program, and I think it does. Okay, so when you draw a straight line in Photoshop, right? I'm going to put it on a different layer for a second. When you draw a straight line in Photoshop, there's absolutely no anti-aliasing on it, right? If you use the pencil tool. So this is an exactly perfect 1 pixel line, right?
Okay.
If you take this line, you rotate it by some number that's not nice.
Yeah.
It's screwed, right?
Okay.
However, if you take the exact same line, right, and then you do, you can maybe, how's the best way of doing this? The best way of doing this is here, and then we can blur it. So if you blur the line, you sort of get an anti-aliasing effect, and then you adjust the levels a wee little bit here. So now what you have is exactly what we would have implemented. This is an exact 2 pixel fall off. So the amount of anti-aliasing for this line is exactly 2 pixels, right?
Okay.
So if you're looking close, you got your one solid pixel in the middle, and then you got some amount of, this is all alpha, by the way, there's no color in this. So you got some amount that your alpha value stepped down 1 pixel away, and some amount that your alpha value stepped down 2 pixels away, right? So now when you take this line, and you put it back here, and you rotate it, some weird number, it looks substantially better, right? And that's because you got this amount of anti-aliasing happening, right?
Okay.
And if you were to take, sorry?
So correct me if I'm wrong here, but just trying to understand that part. So in some sense, you're not really talking about anti-aliasing. You're more just talking about radial fall off, because an anti-alias line would only have at most one pixel of non-1 alpha.
Yes, if you're talking about like the strict
sense?
definition of like you're doing triangle like FXAA, or you're doing multi-sample anti-aliasing.
Like coverage based, if that
if
makes
you're doing
sense.
coverage like that sort of no, it's not that. This is a very different type of anti-aliasing.
Interesting. Okay, so tell me a little bit about that. So how did you decide, or why was that the approach that was taken on this, as opposed to maybe the more traditional concept of anti-aliasing, which is just to figure out how things touch the screen pixels?
Right. So the idea was when you start moving these lines, and if you take a line and you stretch it out, or you take a line and then you bend it, you get it looks better. And when you start moving these lines, and we did tests, it actually looks better. This looks better for high contrast line art than simply doing FXAA or something like that. I mean, if we were to do like 16 by 16 multi-sample or something like that, where maybe then it would look good, but that's just prohibitively expensive. So I think 4x4 is what the PS4 supports natively. I don't remember. Whatever it is, like I think it's 4. I think you can take 16 samples per pixel on a PS4.
Okay.
It doesn't look as good as this.
All right, so I get it now. So back to the original thing. So that was what we were trying to implement, was this fall off.
Yes.
Okay.
And we did it through the side distance field thing.
Okay, so now go back to the thing before and just give me the square root versus non-square root thing. So.
Okay, so when you do the square root, that's fine for when you don't want it, when you just want to hard step it. Mm-hmm. I think maybe there's too much emphasis placed on the square root thing, because I was just like, oh, we could save a square root, but never actually did, because who cares?
Okay.
But it's worth talking about, I guess.
Okay.
So when you do this, you have some sort of do I still have that image here? Nope, that's something completely different. Let's not look at that. When you actually just look at the values of the sign distance field, right, you get like I drew before, um, you get this, right? And so you have to take, well, you get this. So this is the 1 to 0
Right.
vector. It's just a simple vector gradient, right?
Yes.
So what you have to do is say you want your circle to be, maybe this big, right?
Yeah.
So if you want your circle to be this big, then you have to figure out how to map from this gradient to this, right?
Mm-hmm.
So there's ways, like I said, the first example that I gave you was the step example, right?
Yeah.
Another example is there's smooth step, which is actually what we used, which is a cubic Hermite spline. Do I need to go into that?
Yeah. A cubic Hermite spline.
Okay, I don't know the actual definition of a Hermite spline, but a cubic function is, a mathematical function. Y
Right.
is equal to, or I guess we don't use y in math. We go, f at x is, what is it, I'll use t because t is sort of the traditional. F at t is equal to, a t cubed because it's cubic, b t squared, c t plus d, right? So
Okay.
any function that has this property has two, I guess they're called inflection points, has two inflection points in it, where so the curve might look like, let me see if I can get because we want the curve to be like that. So, we'll have a curve. This is a cubic function, right? So you have an inflection point here and an inflection point here, right? And this is going to be monotonically decreasing here, monotonically decreasing here, monotonically increasing here, right?
Okay.
It could be flipped, right? But you're going to have three monotonic sections, right?
Okay.
With two inflection points, right? So
Okay.
I believe the definition of a cubic Hermite spline is f at t. I don't know if this is the correct technical definition, but this is good enough.
Yeah.
So
Yeah.
you're going to have f at t, or sorry, not f at t. You're going to have f at 0 is going to be equal to 0. F at 1 is going to be equal to 1. The first derivative of f at 0 is going to be 0. And the first derivative of f at 1 is also going to be 0, right? So that just means that, it's completely flat here. It's completely flat here, right?
Okay.
Which is going to be at all inflection points, right? But
Okay.
the point is that it goes from 0 to 1, right? So at this point here, so if this is f of t, on the, this axis here, this is 0. And then you come across here on this axis here, this is 1, right?
Okay.
And then if you solve for all this, as soon as you go f at 0, so you set all these to 0, so that knocks out 0. That knocks out the d parameter because d has to be 0. And then when you do f prime at 0, right? So your f prime function is going to be, 3at squared plus 2bt plus c. So if f prime at 0 is also 0, that means that this is 0 and this is 0. So c is also equal to 0. And then you can do you just set it up as a linear system of equations, do, Gauss-Jordan elimination, solve it. And then I think you get minus 2t cubed plus 3t squared.
So
that's
basically,
your function.
this cubic Hermite spline has essentially no parameters. It's hard coded to be just this one little lump.
Yes, it's this. This is the function.
Okay, got it.
So it takes all of this, and that's how it takes this normal cubic function, applies these parameters, what f at 0, what f prime at 0 has to be. You fill it all in. You get yourself systems of equations of what these two things have to be 0, because at this point you only have two unknowns, so it's completely solvable, and you get this function, I think.
Okay.
Pretty sure that's what it is.
All right.
So that's what smooth step does, right?
Okay.
So what you do is you take that's not what we wanted. Where is Photoshop? So basically what it does is it takes this gradient that we have here, which is going to be a linear gradient, which is, so if you look at the fall off, it's going to be like that. And it takes it, and if you put all of the parameters in, it maps it to be, let's use blue, it maps it to look something like that, right? And that's going to be this part of the
I see.
cube. So this here is where we do, is how we determine the coverage of each pixel. So instead of just doing a linear fall off where we do a fall off and we say if it's greater than this, if it's greater than this, 1, if it's less than this, 0, you apply a smooth step to it, and you sort of clamp the range, and you get some sort of a gradient fall off where it's probably equivalent to, I don't know, let's see, if we were to use Photoshop to all of its glory, you get something. This is a really exaggerated.
Yes.
This is a really exaggerated fall off, but you
Got
get
it.
this, right? That's the
Okay.
effect that you get.
Got it. Okay, so I have one more question, just because it's almost time for me to let you go to the next interview here.
All right.
So one more question I had is, just going back to something you said earlier, you were like, the functions we use for the distance field, we use Christopher Erickson's derivations for something, and I didn't quite have a chance at that point to ask you, sorry, what is the something again? What are the actual primitives that you were talking about there? I think you said 2 points or an arc, or what were those? What was that set for?
So a line segment, which is just 2 points, and a circle arc, which is, I guess, two radians, like how far around each point of the circle it is.
Okay, so
or was it?
Tell me the line segment one. So show me that there. Again, I know that you were saying that you didn't derive these, so I'm not trying to ask you that. I just meant like tell me a little bit about that process, so I kind of get that part.
Okay, so we'd have a pixel shade. We'd have a shader. Actually, there's another interesting part of this that I hope we have time to get to, which is double coverage pixels, which was the actual problem with this algorithm. That was the hard part.
We may not have time to get to it, but we could.
Okay,
let's just tell me this part first, and then we can.
Okay, so basically, you pass to a pixel shader. You would pass 2 points, P0. We'll call them P0, P1, and then instead of doing the point to, like in the previous example, right? We had a PC, and we had all of the points in the square. Okay. So we would generate the same square here. And instead of doing distance to point, we did distance to line segment, and then the line segment are defined by these 2 points. And in order to draw the couple 100,000 things that we did per frame that were all computed on the CPU, all of this stuff was done in a single draw call. So
I see.
We batched it up in a draw call. So each vertex actually had a lot of redundant data.
Okay.
Because each vertex sent the P0 and the P1. Because you couldn't do... Like now you can inject like variables and do weird draw call stuff with modern OpenGL, but you couldn't do that on the PS4. Okay. So basically, there was a lot of redundant data built into the vertices.
So you have to find, because I understood the part about finding the distance to a point that we were talking about before. So if I want to talk about the distance to this line segment, I suppose, so is that something I can do with a single equation, or
no?
So how does that work, kind of? I mean, to the extent that you can tell me.
How does it work? My guess is, and I haven't looked at it, but my guess is, let's say we have this point.
Okay.
We can get the distance between these two. I don't know. We can draw a triangle. We can get the area of the signed area of the triangle, because, okay, so this is PC or PQ, I guess, query point.
Okay.
So if you make two vectors, V0, PQ, I'm just making this up. I hope it's correct. P0.
Oh, yeah. I mean, I said, like, this is just, I understand the fact that you were saying that use the other one. So I'm not, didn't expect you to even know it. I was just curious. I'm just interested to see.
All right. So we can get these two vectors. And if you take the, V0, X, V0, V0y, V1x, V1y. You take the determinant of that, which is that correct? Yeah, so it's V0x times V1y minus plus V0y dot V1x. That gives you the area of the parallelogram. Half of that area will give you the signed distance. So you take the determinant of that over 2 will give you the signed distance of that, and a triangle's
signed distance of what?
Sorry. It gives you the signed area of the triangle.
Okay.
So it gives you the area of the triangle, or the area of the triangle, right? Because it's the determinant of this vector and this vector divided. That gives you the area of the parallelogram, and then over 2 gives you the area of that, and then formula for triangle is 1/2 BH, right? Base times height. So if we treat this vector here, we can get the length of that pretty easily. We can't get the height. So height would be our distance, right? So we know what that area, what base is. So half of base, which we know, height is equal to, the determinant of v0, v1 over 2. We can multiply those out and then take the height is equal to that determinant the base. Well, we know what the length of the base is, so if we take the height, is that over the base, and we get the height, which I guess is the distance to that, but that would only work if that is constrained within this region here. So maybe there has to be an if to be like if the query point is outside of that range,
So
then we have to use.
okay, yeah. So wait, I think that makes some sense. So maybe can you scroll down a little bit here? I didn't ask that question. How would we do that? So let's say we had just that line segment, and we wanted to go like, okay, is PQ inside that region?
Oh
how,
God,
how would we do that?
That's a Voronoi region, or could we use barycentric coordinate for that? I don't know. I'd have to look it up. I don't know off the top of my head. I'm sure. Well, there is a Voronoi region formula for it because we can tell if it's in which slab it's going to be in. But off the top of my head, my geometry knowledge would see me struggle greatly to solve this. And this is something that I would just Google.
Okay, yeah. Well, so that I guess the way you drew it there, right? You've got kind of line. You sort of
It's
made.
pretty.
What is that? That's perpendicular, I guess. Those lines that you drew there to the line segment.
Yeah. So we could, because you could generate a triangle here, and then if you dot this with, you can figure out what. Well, no, you do another. Because you could do this, generate this triangle, figure out the winding order with the determinant to figure out if it's inside of this side, and then do it again on that side. But there's no way that's how it works, because that's way too much. It was way simpler. It was way simpler than that. So you could figure out this triangle, right, and then figure out the winding order to tell if this point is here or this point is here, and then you could do it with this triangle here, and then do I have to go over what?
No, I totally got.
Okay, so you could do that, but that's not how it was done. It was way simpler than that, and I don't remember how it was done.
All right. Well, I don't want to take up any more of your time here because we are out of interview. You're gonna need time to walk to the next office, basically.
Sure.
But thanks so much for explaining all that. That was awesome, and it was great meeting you.
All right. Well, thank you very much.
Thank you. All right. That concludes the interview process. How did it feel, Shawn? Was that reasonable or not?
Yeah, I mean, I don't know how my answers were. That's what I'm sort of curious about, right? Because I don't know.
Well,
like it seemed fine, but like I don't know how. Like it seemed like the questions were all reasonable, and it was sort of like, just explain this to me. But like I know that you know this stuff, so I'm like, oh fuck, why is he asking me to explain this, right?
Yeah, well, that's the part that we can't get around for this. So I was going to mention that. It's like, so normally, just unpacking the interview process, right? First of all, that was perfect. Like, that was exactly what I would have wanted. And it tells me, like, everything I need to know about the person, right? Because, you can see how basically we essentially did all the sorts of stuff that you might expect to do in a programming problem style interview, but it was all stuff you already had been familiar with. So you didn't have to like come in cold, and you could, in so much as was possible, given that you already know me, I'm at a bit of a disadvantage. But you get to be in the authoritative position, which is the really important part, right? You're telling me how this thing works, not me asking you a problem that I know the answer to and you don't. Do you know what I'm saying?
Right.
And
yeah,
so,
no.
Yeah, and so the problem is, I know all the stuff I was playing dumb about, which makes it harder because you're incredulous when I say stuff like, why don't you need the square root? Normally, an interviewer might just think I'm that dumb, right? Like, they don't know.
Yeah, that question actually threw me off because I was like,
yeah. What
do you mean?
Of course, right.
What do you mean, why?
But, when they're just walking in here, I could just be some idiot, right? And that's okay, or maybe it's not my area of expertise. So,
right.
So, that was certainly going to be harder for you because you knew I knew it already. But that's how you have to do those kinds of interviews, because I need to see how comfortable you are with this stuff. And it's obvious, right? I mean, you were able to explain it all and be very clear about it and whatever, so that's exactly what you want to see. But you can understand how a lot of people, maybe they looked up some stuff that Christer Erickson wrote and just typed it in and have no capability of explaining to me like what smooth step is or why you would use it or any of that stuff, right? And so what you're trying to do is like pull that stuff out and see to what extent does this person really understand what they've done. Right? And it becomes very clear very quickly, right? Either it ends up looking basically like what you did, where you get pretty excited about it and you're showing me some diagrams and you're like, see, this works like this, and this is how this works, and like, oh, okay, here, you didn't understand that, let me show you this other way of looking at it. It quickly either goes that direction or I'm not sure, like whatever, I really don't know, right? Do you know what I'm saying?
Yeah, and what I find interesting is I thought you were, like, I didn't know much about what this process was beforehand. So
right.
I thought you were like, the difference is I thought you were going to be like, no, write the two equations that are needed and solve the linear system of equations to get the Hermite spline. Is that the Hermite spline function? Is that what that means? I don't even know. Math terms, I don't know.
I have no idea. I always rederive all my curves every time, so I have no idea what the names for the various, because all cubic curves are a cubic curve, right? They are all the same. Right. So everyone just wanted their name attached to some. So it's or did Bezier get his name on this one? I don't know. So I have no idea which one it is. Yeah, and I don't care. Again in the interview, the only thing I cared about was that you could show me that, right? Because then it's clear. It's like, yes, I don't even care if you solve it correctly on the whiteboard because I'm horrible at that kind of math. I would probably make a mistake. So I'm not even looking. What I'm looking for is your confidence in the process and what the things mean. And so as long as I've got that, I just assume that if given 3 hours to solve for a Hermite spline, you would be able to, because it's unlikely that you couldn't open Mathematica if you needed to or something, right? Even if you were that bad at solving or something and get the correct answer. Or like you said, Google it, right? So I just want to see that your brain is capable of putting all these things together, understands the picture, and knows what's going on. Your ability to solve the math is not so interesting because, again, that's not something that you do in programming that often with no assistance, and especially not in a limited amount of time, right?
Right. Yeah, and that's the other thing is like for almost all of the answers that I've seen in like this is what the whiteboard questions are, right? It's just like I would just use Google. Like
yeah, right.
What data structure should I use in this situation? I don't know. Some sort of a tree. I'll just Google it, right? Like the answer is almost always, why would I even have this information in my head?
Well, that's why again I like this style of interview. It's because you have some process that you've gone through to do programming, right? And research is an important part of programming. You don't typically want someone who's going to rederive everything from scratch every time without looking to see what other people have already done, right? That's not a particularly great approach to programming because there's a lot of smart people out there and they've looked at this problem and you want to know what they thought. So one of the big reasons that I like this style is you've done that process, whatever your process is, for this problem, right? And now I'm asking you to explain back to me what you figured out. And if Googling someone else's work on it was part of the process, that doesn't matter to me. What matters to me is that you understood afterwards what happened and how that fit into what you were doing, why it was the right decision or whatever, like all those sorts of things. And I can tell that when you're talking about something you've already done. When I'm giving you a problem cold, you never have a chance to go through your standard process, so who cares what you do at that point? You're not doing what you would normally do, right?
Right.
So,
by the way, if you can see it, that's the actual formula.
I actually already know how to do it.
Off the top of your head?
Yeah.
How do you know how to do it off the top of your head?
Well, so looking at it, right, I mean, this is the thing, is I spent all that time doing GJK, and that's the second case in GJK.
Okay.
Right?
Yeah, because I haven't actually implemented GJK.
So the dot product of the vector of the P0, P1 vector is pointing in the direction you need to dot product against to test which region you're in of the 3 regions.
Okay.
You know what I'm talking about?
It is the Voronoi region.
So once you get that dot product, you know which region you're in. If you're in either of the 2 end cap regions, you just need the distance to the point.
Right.
which
Right.
you already have. It's just a fallback. If you're inside the region, then it's just the perpendicular, which, hey, is the cross product. The length of the cross product is going to be the distance from the line segment out
Well,
to
that's
the
only
point.
in 3D though. In
It's
2D,
an all D.
so you just do a perpendicular dot product.
Yes, perp dot.
Okay. Perp dot. Okay. Okay. All right. Well, shit.
I shouldn't say all D. It's not an all D. You need the, what is it? The wedge product. You need the 4D correct one to go out. But right.
Right.
So
right.
yeah, I knew how to do it, but this again, like so looking at that process, right, and kind of going back to it, unpacking it now for people who are watching. And again, like I said, this entire stream is it designed to instruct the interviewer, not the interviewee, right? The stream has nothing to do
my answer
with
is
it.
actually stupid then. Like I'm looking at the code now, and my answer's dumb. Like this
well,
is not a good way to determine the distance.
Right. Well, so again, okay. So let's unpack the whole interview if you want to talk about the whole interview, right? So you can see how I structured the interview, right? The first part of it was just talking to you to establish some kind of a rapport, so that the person doesn't feel like they're being slapped with tech right off the bat, right? So I just
Sure,
want to talk. You know, and I thought that was really interesting too. It was interesting personal perspective too that just happened to come out. I wasn't necessarily going for that, but it was neat. I learned about, you said you enjoyed competitive things, that you liked esports, and here's why, and you didn't really love playing games as much anymore. So I got to learn something about you, which is great too, right? If the person is forthcoming about certain aspects of that, that's a really nice thing to know too, because now you just have a better connection with that person. You're going to have an easier time interviewing them, certainly, and you know something about them that maybe is relevant to their job, maybe not. Who knows, right? That's a hard thing to say. But so that part is kind of irrelevant to the tech side. It's just to kind of get things warmed up. And then from there, you could kind of see I went through about a 10-minute process, and this part is very important to get right. I'm a little rusty at it. But hopefully I did okay, which is trying to get you into a position to start talking with me about tech specifics. So you saw me kind of get you down towards a specific technical area that I could kind of just start asking questions about. And it did not matter to me where that was, right? I just needed you to be somewhere you felt interested in explaining something to me. And so you saw me I poked around that with the asset streaming a little. It didn't seem like there was really, maybe that much there to really explain. So I I pushed around a little bit more. The dyad thing came up when you started talking about the United States. It seemed like you were interested in it. So I was like, okay, I can get all the tech stuff I need out of this. So let's just go there, right? So then I asked you a bunch of stuff to explain to me throughout the course of that. And basically, like, I noticed that, most things you felt very comfortable explaining. The distance one, you didn't, the 2-point distance one, you didn't want to explain, right? You left it out. Because you didn't know.
I didn't drive it, right?
So what I did is I pushed that one to the end, because I wanted to spend most of the time on stuff you were comfortable with, because that's the most important stuff. And then at the end, I was just like, okay, I'm pretty confident this person knows what they're doing, right? I liked everything I heard, right? Like I was like, he explained it very eloquently. He drew diagrams that I understood. He was patient with me, right? You didn't get annoyed that I was asking these questions, which again, in this circumstance is even doubly good because I know the answer to a lot of these things. So you getting impatient with me is even more on the table, right? But you didn't. You took the time to explain it, which was great. And so at the end, what I wanted to do was just go, okay, since I'm very confident that I've gotten, good answers on anything else, let me just see what happens if I just throw something at him that I know he's uncomfortable with, just to see where he goes. And so that was all that was to see that. If I had more time at the end, I may have pushed you down to actually trying to solve it. But I wasn't super interested in that, so I didn't prioritize that in terms of time.
Well, I think my solution would actually work. It's just terrible.
Exactly, but that's okay because a lot of times the first solution is terrible.
Right.
A lot of times my first solution to any programming problem is terrible, and I expect yours is too. All I wanted to see was how you were thinking about the problem. What do your attack skills look like, et cetera, right? And so that was it. So if we'd had more time, or if I really wasn't sure, because based on all the answers you were giving me, it seemed like you were capable of working through these things, so I wasn't super concerned about that. Maybe if I had been more concerned about that, I would have spent more time on it. But at the end, I was like, let's just see what it looks like when he attacks the problem. That was all that was.
Yeah, it was good. I thought you were going to go deeper. Like I thought the whole point of the interview originally, before I knew what it was, would have been like, no, you have to solve this, right? And I would have thought that for the Hermite spline, no, you have to because I knew it was minus 2t cubed plus 3t squared, right? I remember that, right?
But
I thought you were going to be like, no, take your 4 formulas, cut them all out, figure it out.
But I guess, I mean, from my perspective, you could cut and paste what you just told me into Mathematica and it would produce the answer. What I wanted to hear there was, okay, here, I understand the concept of a cubic equation. I understand the concept that if I constrain enough points of it, then it will solve down to a fixed answer. That's the important part. I don't care if, we have computers that will solve that for you after you know that, right? So me wasting your and my time on a whiteboard solving a cubic equation that's like a high school AP calculus class thing at best.
Right.
I mean, if for some reason you couldn't do that, we could teach you to do that on the job. That's like rote skills, right? So
yeah.
It just doesn't matter. It's not the thing that's going to determine whether you're going to be an asset to a team. And so I feel like interviews that focus on you doing a rote process that we know how to do and that computers can do, it just doesn't make sense. Hearing you understand how a Hermite spline comes about, that's crucial. If you were just like, I don't know, here's the formula, and you just wrote the formula up, then I would have pushed to go, okay, how did you get that right? But you had already told me by the time you wrote it out, you'd already told me how to generate it, which is exactly what I wanted to hear, right? Like you told me exactly what I wanted to hear before I didn't even have to ask a question, right?
Oh, okay.
You see what I'm saying?
Yeah, and there was another one where I was like, do you want me to explain this? And you were like, no. What was that? Do you remember? Because there was something else that I was like, this is something that I think you'd want me to explain.
I'm not sure. Sorry,
okay.
I don't know.
I don't know.
Because, again, almost all of the questions that you oftentimes would go ahead and work out an equation on the board, which may be because you thought I want to or whatever, but you'll notice almost all the questions I asked were, I just wanted an explanation. And I wanted that explanation to be clear to me that you understood the reason. So, for example, you noticed I asked a bunch of times about square root versus non-square root.
Yeah, but which threw me off because it was like not an issue at all. It was just like, oh, if you're only stepping, you don't need to waste your time with the square root, right?
Right.
That's the only thing. It was such a minor issue that you kept asking about. I was like, what is going on?
But you can see why, right? It's because I wanted to make sure that I heard the answer, which is essentially, oh, okay, there is a relationship in a sign distance field between the iso value, right, the radius which you had there for the thing, and the equation on the other side. Because all I care about is that relationship, right, being equal to a particular value. It's free for me to square both sides of this thing, and I don't have to worry. But until I heard the square the radius, I couldn't be sure that you actually had thought it all the way through, right?
Right. So when I answered that question, I went through like, okay, I drew the whole equation out and I put r, and I was like, you take this. Did you want that, or could you just be like, square the radius? Like, what was an acceptable answer for you?
Well, again, and this is crucial. The whole point about this kind of interview style is it's not an answer. It's me making sure I've heard enough so that I know that it's 100% solid in your head, right?
Okay.
And like I said, in a lot of these cases, because I already know you, I know it's already solid in your head, but right? I potentially already know the answer. But in order to show the interview process properly, I tried as hard as I could to go, assume Shawn doesn't actually know or might not know, and let me actually do what I need to do to demonstrate to myself that he does. Because that's the point of demonstrating the interview process, right?
Right.
And again, we have to assume that someone coming in the door doesn't necessarily know these things. A lot of people, a lot of programmers would fail to be able to really lucidly explain a lot of the stuff you just explained. That's just true, right? We take it for granted because a lot of times we're talking about very good programmers when we talk about it, like a lot of people mentioned on these streams, you or Shawn or Fabian or John Blow. Of course they know this stuff, and of course they can explain it. That's not the common case, right? And when you're interviewing for these things, and you're looking to see if someone's really technically competent, it's not at all a given that someone's going to be able to explain those things in that way. So I'm not looking for an answer, right? I'm not looking for you to say square the radius. I'm looking for you to say enough stuff so that I can see that in your brain it's all worked out the right way. And that sometimes may be as simple as a few quick sentences. I'm like, okay, he obviously has it. Other times, for whatever reason, maybe I haven't quite heard enough yet and I just want to be sure. And then that's where I need to drill down. So that's all it is. And there isn't like, none of the things I asked you had correct answers to me at all. They were just, let me see how this person thinks about the problem. And once I see that it's fully formed, I'm satisfied, right? Does that make sense?
Oh yeah. I think I think if I ever had a job interview, this would be fine.
Yeah, and hopefully, like I said, barring the fact that a lot of things were weird for you because you didn't understand why I didn't understand them, or why I was asking you something that you knew that I already knew.
Oh, you put doubt in my head. I was like, am I explaining this like an idiot?
No, and so I apologize for that part, but that, again, hopefully wouldn't be a problem in a normal interview process because you wouldn't know the other person was an expert on 3D or something, right?
Right, and that would actually be a difficult thing. It's like, if I don't know who's interviewing me, is it like an HR person? Because if it's an HR person, like, oh my God, what am I doing? Like,
well, they're not going to know how to interrogate you in that way. They're not going to know how to interrogate those kind of technical problems. An HR person would be lost because you notice my questions to you were always based on things you had just told me. If you can't follow a technical discussion, there's no way to conduct that interview. So it has to be a programmer, and it has to be a programmer who's relatively good. Ideally, the programmer does know all these things, but maybe they don't know them. Maybe they don't really know that much about sign distance field. Again, that's okay because what you're trying to do, as you assume that the interviewer is a smart technical person, just because they don't know sign distance field, that's all the more reason that that's a good way to go about this interview. Because if you can't explain it to me, if I'm a relatively smart programmer and you can't explain it to me, that's a problem, right? Because if you really understand the material, you should be able to explain it to me slowly, easily, as long as I'm not asking too big, right? And so, either way, I think it works. If the person doing the interviewing doesn't know that discipline, but is a relatively smart person, that's okay, because then it's literally like you're just my teacher. I'm just treating you as my teacher for 30 minutes and seeing how much I feel like I really got the understanding of the material at the end of it. And that, to me, is a really good style for the interview, much better than programming puzzle.
Yeah, programming puzzle doesn't sound good. This seemed reasonable. Like, if I ever applied for a job, which no, and
these days, right, it's not so relevant, but yeah.
Yeah, no, I don't want to. Yeah, but like, if that ever happened and like I had to interview like this, I'd be like, all right, this is somewhere where they at least are trying. Maybe I'd want to work here. Like, this is much better than like, what was the one that guy invert like an AVL tree or something like that on a whiteboard? It's just like, no. My answer to that question is no. Like, I heard another programmer interview was design a lock-free queue on a whiteboard. No.
Right. All of those things are to me, they tell you a lot about what the sort of criteria is for working at that company, and it would make me nervous about the kind of people that I might be working with at that point. Because if I know that the general criteria for becoming a part of this company is there people who have to perform relatively well under pressure like that, that to me is not the filtering criteria that I really want, right? I don't really know who I'm going to be working with at that point. I don't have confidence that the team that I'm going to be working with has been screened in a way that actually produces high quality people on the other side. It's screening for something totally unrelated to that, I don't know if this is going to be a good programming team. I have no idea at that point. And furthermore, one of the things about this interview process that's nice too is it means that in general, you're going to select for people who can explain things to their coworkers, who don't get frustrated with people who don't understand stuff, because they've had to go through an interview process where basically they were the expert and they were telling someone something about what they did. And that's a valuable skill day to day, right?
I never thought about it from that perspective. And yeah, that's like the most important thing.
A programming puzzle is not a skill you will ever use again. That's not something you're going to ever do again in that way, right? You're never going to be presented with a isolated, high-pressure, time-limited thing. What you are going to have to do, oftentimes, is someone pops by your office. I don't understand the anti-aliaser, and I got to fix this bug. Can you just tell me a little bit about how it works? Oh yeah, sure, Casey. Here's like you draw the thing up here, and like you said, I don't really remember how we did the 2 sign distance field thing, but it was Krister Eriksson's. You can go look out on the web. What you gave me was exactly what I needed to know to go fix the anti-aliaser if something was broken. That's a real situation that will come up day to day. So also, in addition to I think it being a good interview process, it also actually does bear resemblance to something you will do day to day, which I think is important. You know, that's what the interview should be built around, not something you won't do, right?
Yeah. This is definitely much better than
yes.
program interviews. Thanks, Checker.
Thank you, Chris. Thank you for and I don't know, maybe he didn't come up with it. All I know is I learned it from him. So you'll have to tell. Maybe someday he can stream and say how it came about, because I actually have no idea where it comes from or why it comes from. But that's it. So I guess we can probably wrap it up, and you can give your voice some much needed rest. Thank you so much for doing the mock interview. Hopefully that was useful to everybody.
Fun. I enjoyed that. Now I learned
thanks
something.
for explaining all the sign distance field stuff. Everyone on the stream probably now knows. Well, but everyone watching.
Don't do this. Don't do this to. But like, it's important to know that the vertex winding thing, I guess. But like, don't do this to figure out the distance to a line segment. Go get real-time.
That was one tiny little part. All the rest of it was sign distance fields 101 education course, which is useful to people.
Go get real-time collision detection. It'll answer all your questions.
All right. Maybe I'll have to order a copy.
You don't have it?
I don't. No.
You probably. Well, it's just basically I have it for all the distance functions. It's just like
it's like here they are. Yeah.
Here they are. It's like okay, great. I have them now. I never have to think about it.
Yeah. All right. Well, thanks so much, Shawn. I will hang up the hang-ups now.
Okay.
Are you streaming today? Are you streaming when you streaming next?
I was going to. Probably in half an hour. I guess I will.
All right. Well, there you go. So if you want more Shawn, he'll be streaming in half an hour.
Wait, you're not doing Handmade Hero, are you?
No. That's it for today.
Okay. Then
what's your Twitch handle?
SSS McGrath.
It's SSS McGrath.
Yeah.
I always have to check the number of S's.
I pressed S's until it wasn't taken.
How come you don't do McGrath? How come it was and not? Don't know. All right.
No, I don't remember.
All right. Thanks so much, Shawn. And
thank you. That was great.
Take it easy, man. Okay. Well, if you want here, we can take a few quick questions if there's any questions from people watching on the stream. I don't know if that was a reasonable enough sort of illustration of the process. I hope that it was. That went what I thought very well. That's exactly how you would like a good interview to go, I think. For me, if I was actually interviewing Shawn, I feel like I would have had all the information I needed. But I don't actually know what would have happened. He knows all that stuff and is very good at explaining it. It might have been the sort of thing where it would be interesting to see what happens on someone who doesn't really know stuff. But I don't want to put anyone in that position on the stream, so I don't feel comfortable demonstrating the no hire, right? Shawn's kind of an example of this is someone interviewing who you are going to hire, right? And so, demonstrating the obvious part, the counterpoint to that, which is what it looks like when someone doesn't do well in the interview, and probably, this is someone you shouldn't hire. I don't really feel like demonstrating that is okay, because I don't want someone to look bad on stream, right? And so you'll just have to take my word for the fact that when someone doesn't have a really tight grasp on the material, as you drill down into it like we did, their answers will fall apart, and they can't really explain anything to you, and they don't really know what's going on. And that's typically what happens. So, like I said, I don't feel comfortable demonstrating that, but you can sort of take my word for it that it does work, or you can try yourself and see how your mileage is on it. Okay, Sergio says, I believe I'm good at these kinds of interviews, but often my main problem is just getting my foot in the door. What advice could you give to make it more likely for me to actually get an interview? So I think the thing that I wanted to say there, and oh my goodness, my head is actually missing. I don't know why my head is missing from the stream. That's interesting. The webcam is supposedly there, right? There's webcam, but you know, I'm not visible. I don't know why. Well, there's that. You know what? I'm not going to try and fix that. I'm just going to be a disembodied voice for the moment because I don't know. It looks like, honestly, it looks like my webcam is not even on, which doesn't really make any sense. I wonder if, because we were just seeing it on the Hangouts, so I wonder if like it got shut off for some reason. Yeah, I don't know what happened there. That's a very good question. Hold on 1 second. I'll see if there's anything that can be done about that. I apologize for that, but you know, that's just some reliable computing going on there. It may have been because 2 applications were trying to access the webcam, for all I know. And I'm not sure if that's like a kind of thing that they can not really handle particularly well. I wish there was some way to reinitialize the webcam, but I don't actually see any particular way of making that happen, right? Like, I kind of need to tell OBS, like, hey man, can you go ahead and sort of initialize yourself? And I don't think it's gonna want to do that without, I could probably like shut it off and turn it back on again, but then the stream would have to go down, which is less useful. So I don't really know any other way of getting this this saucy gentleman here to do that. So you'll have to deal with the disembodied head for, or disembodied voice rather. So what? Let me go ahead and sort of answer these questions a little bit. Let's see here. So Sergio, I wanted to answer your question of any advice you can give to make it more likely to get an interview. So I just want to make it clear, this stream is strictly for interviewers, right? This stream was just to sort of demonstrate, hey, if you're interviewing in tech, here's another way to interview that I think is a lot better than the high-pressure program puzzle kind of way of interviewing. Maybe consider doing it because A, I think you get better hires out of it, and B, I think that it takes some of the adversarial nature and the unpleasantness out of the interview process that currently is going on at a lot of tech companies. And so that was it. I have no advice for interviewees. I have none. I don't know anything about that process. I do not know anything about how to increase your chances of getting an interview or how to pass HR screens or any of that stuff. So I have no advice to give there. I was just trying to illustrate for the other side, hey, here's how it goes, right? Miblo says, Shawn was great, obviously, but I think that interviewees could also maybe do with having a bit of a plan as to which rat holes they'd be prepared to go down. So to a certain degree, yes, and to a certain degree, no. One of the goals of this interview process, and I knew that it would be relatively easy on Shawn because he was not familiar with the interview process to begin with. One of the goals is to push the person into the area that you have picked and not really let them dictate the area too much, because yes, they may have started like rehearsing for programming Hindus in that way. You want to try as much as possible to keep them explaining things that maybe they weren't necessarily expecting to explain ahead of time, in so much as you can. So take that for whatever it's worth. But Mr. Fourth Dimension, I am curious how you would move forward with the interview if someone doesn't have a lot of interesting past projects that they are excited to talk about. Does this just assume you're hiring experienced people? Well, it depends what you mean by that. So no, it doesn't assume you're hiring experienced people in the industry. It does assume that you're hiring people with programming experience, right? If you are hiring literally for people who don't know how to program, then yeah, right? It's not for that. But I don't know anybody in the industry who hires people who don't know how to program. Maybe there are some who have like boot camps and stuff that try to just take smart people and train them to be programmers. But assuming that you're talking about someone who knows how to program, you just don't know how to program in C if you haven't programmed for many, 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 many hours, right? That's just a fact, right? So if this person is going to be at all qualified for the job in any way, they have at least done a bunch of programming in school or in their spare time or something, because otherwise they just don't know how to program yet, in which case you definitely don't want them, right? So they don't have to have done any past projects on the scale of what Shawn has done, for example, whole games, but they must have done something. They must have done, if this person hasn't done 5,000 hours of C programming or something, right? Then I don't know why I would be interviewing them at all. Even for an entry-level position, they're just not going to be good enough at C to really be part of a team, right? So you'd, under that limit where you don't have anything in their past that you can talk about, that person is really not a programmer yet in my mind, right? So Shawn obviously makes it look maybe a little more grandiose because we're talking about entire projects, entire games he's shipped, and we're drilling down on those. But that thing that you start drilling down on could be anything. It can be a school project, a particular class that they took, that they liked, and what about it they liked, and to explain things that they learned in it, right? So you don't have to have the kind of breadth that Shawn was presenting. You just have to have enough hours to actually be a competent programmer. But if that's happened, there's going to be stuff you can drill down on. And so that's really all you need there. I think I got all the questions. Do you think streaming yourself online maybe is even helpful for interviews like you do? Possibly. I mean, one thing that I would say is on the interviewee side, if even taking that out of the thing, because like I said, I don't have a lot of advice for interviewees. But one thing I would say is part of being a good programmer on a team, if you're just programming by yourself all the time, then it's not so necessary. But part of being a good programmer on a team, like we were sort of saying at the end of the interview there, is being able to explain what you've done to other people in a way that they can understand, right? And so doing streams where you explain programming stuff or just having practice explaining things is just a generally good programmer skill to have in general. And the fact that it would help with an interview like this one is just kind of a bonus on top of the fact that it's just a good thing to know how to do. So it is, I think, true that that is the sort of thing that you might want to practice. And if streaming is a good way for you to practice it, then that would be good, yeah. Looks like we've got everything, I think. All right. All right. thank you everyone for joining me for this special edition of Handmade Hero, where we went over how to do tech interviews that are non-confrontational, or at least as non-confrontational as possible. Hopefully that's something that some people out there might consider doing instead of sort of the programming puzzle, high-pressure version of interviews, which I think are really biased towards hiring specific sorts of people that don't necessarily correlate in any particular way to people who will be good programmers for your team. So that's just an example of how to do it. I tried to do it as best I could. Again, that's not my invention. I learned it from Chris Hecker, and he may watch the stream and feel like I did a poor job of it. In which case, yeah, I do hope that if he has any interest, he would demonstrate it sometime where he could kind of show maybe things that I did wrong, or if there's any like kind of finer points to it that I kind of missed the boat on. Like I said, I only really know how to do it because I watched him do it, and he was very good at it. So hopefully that gives sort of, puts another idea out there a little more broadly in terms of how interviews can be conducted in ways that do get down to really technical nitty-gritty and do force people to really demonstrate their understanding of how things work at a deep level, but which does not require this sort of on-the-spot programming puzzle sort of, I guess, confrontational situation that I think can cause a lot of programmers who are otherwise very good at programming, but just not particularly good at that one situation to kind of fall down and perhaps not get hired at a job where they would actually be very good for that job. So that's it. Thank you very much for joining me. Tomorrow, this whole weekend is basically special programming on Handmade Hero. That's just the way it worked out in terms of scheduling. Tomorrow, I had been meaning for quite some time to try to get Charles Bloom to come and talk to us. He could not make Handmade Con. He was supposed to be on the panel for compression, but he could not make it. And so he agreed to come talk to us separately. And so tomorrow we're going to be talking with Charles Bloom about compression, which should be fantastic because he and Fabian obviously did some very pioneering work in compression just recently, and it's pretty exciting stuff. So getting kind of like his outlook on compression, how he thinks about it, I think is going to be really interesting. So I'm very excited for that. I don't know exactly what time that'll be tomorrow because we're going to do it sort of in person. So you kind of have to play it by ear, but of course it will be uploaded to YouTube afterwards. So if you can't make the stream live, since we don't really necessarily know exactly what time, I can't tell you definitively what time to be here. For that, you will be able to catch it on YouTube. So hopefully that should be good, and everyone can go from there. That's about it. Thanks for joining, and we'll see everyone tomorrow. Until then, have fun programming, and see everyone on the internet. Take it easy, everybody.